Oh, there we go. Oops, there we go. Now we can see what day we're talking about. Today we want to talk about reference angles and quadrants and what we can do with them. Recall that a reference angle is a positive angle going from the terminal side of an angle to the nearest part of the x-axis. That means a reference angle will always be between 0 and 90 degrees, strictly between 0 and 90 degrees. If the angle is 90 degrees, then we're not going to talk about reference angles. So reference angles will always be positive acute angles. We want to combine this with our knowledge of the first quadrant that I asked you to remember from yesterday. Yesterday module of this class, so last Thursday. Last Thursday is the last Thursday that happened. So a good way to remember this is to remember that sine starts at 0 and counts up to 1, where cosine starts at 1 and counts down to 0. And at 30, 45, and 60, they all go through the same values. If we remember that sine of 30 is a half, cosine of 30 is going to be square root of 3 over 2. 45 degrees is where sine and cosine agree. Square root of 2 over 2. Root 2 over 2. Sine of 60 is root 3 over 2, where cosine of 60 is 1/2. So we count up from 0 to 1/2 to root 2 over 2 to root 3 over 2 to 1, where cosine counts down from 1 to root 3 over 2 to root 2 over 2 to 1/2 to 0. We should also know tangents. Tangent starts off at 0, and in the first quadrant counts up to infinity. Pretty long way to go. Remember that halfway there, we're at 1. So 1 is halfway between 0 and infinity. That's not a really good way to think about this. This is an important matchup, though. We could have 0, we could have 1, we could have infinitely many. If you think back to systems of linear equations, those were your 3 choices. Parallel lines is 0. Non-parallel lines is 1 solution. Equations that represent the same line is infinitely many solutions. So it kind of makes sense. I like this 0, 1, and an infinity. Then you just have to remember the other values. Root 3 is bigger than 1, so that tangent of 60 is the square root of 3, where the tangent of 30 will be the reciprocal of that, 1 over root 3 or root 3 over 3. So we need to know what a reference angle is. We need to know this first quadrant, sine, cosine, and tangent of these important angles in the first quadrant. And the third thing that we had is what's positive where. In the first quadrant, all are positive. In the second quadrant, it's sine that's positive. In the third quadrant, it's tangent that's positive. And in the fourth quadrant, it's cosine that's positive. Notice that I didn't bring up secant and cosecant. Secant is positive when cosine is positive, and cosecant is positive when sine is positive. But since I'm just using S to abbreviate sine and C to abbreviate cosine, we're just going to have to remember that part. Three things. What's a reference angle? Know the values in that first quadrant. What's positive where? Let's take these 30, 45, and 60 degree angles and put them in each of the 4 quadrants, because we have to know this first quadrant and how it maps over to the other 4 quadrants. So if you draw a circle, Since the sine of 30 is a half, that will help you find where that 30-degree angle needs to be. So if this is 1, then half of that is a half. And just go straight over. And there's the 30-degree angle. Oh, there we go. So once again, if you go vertically to a half, that's how you can locate a 30-degree angle. I got to use sketchy lines because I didn't bring a straight edge. So if we go copy this over to the other side and hope this part is dry. Right now, the part of my mind that was saying, why don't you just put a ruler in your backpack? I don't remember to grab it before I go to trig. No, it's cool. It's still, everything's all squirrely now. Plus, it'll end up smearing stuff. So what I need is a steadier hand and better eyeballs. Yeah. Yeah, that's what I need to do. I need cybernetic eyes. So here are 4 30-degree reference angles. Each of these is 30 degrees away from the positive x-axis. We want to figure out what these angles are so we will recognize them in the future. So if we have a 30-degree reference angle, that's 30 degrees from the terminal side of theta, 30 degrees from the terminal side of theta down to 180. What's the size of this angle? What is 30 degrees in the second quadrant? 150. So 180 minus 30 is 150. What would be 30 degrees in the third quadrant? 30 degrees after 180, 210. And what about 30 degrees in the fourth quadrant? 330. So here are 4 values that you want to recognize as having a 30-degree reference angle. These should stand out to you. 30, 150, 210, 330. Those should all make you think about a 30-degree reference angle. So that should make you think about this column. I can't see where I was pointing, so this column. That's our 30-degree reference angle. What's that?
Now I see why radians.
Yeah. Radians are cool. It would have been much cooler if instead of pi radians being 180, we use the whole thing, 360, because then the fractions would work out better. But anyway, I missed that meeting. Like, oh, we're going to make the importance of the ratio of the diameter of a circle to its circumference. I was like, oh man, when we have that meeting, I'm going to make sure that we go for the radius instead of the friggin' diameter. I'm like, oh, I want to bring up something about pi. I was like, well, we discussed that yesterday. It's going to be the ratio of the circumference of the diameter. I was like, oh, you idiots use the diameter? And I'm like, well, yeah, why? Because fractions, people aren't going to like fractions in the future. And I go, I'm sure it'll be fine. And it is totally not fine. So anyway. If we want to make the 60-degree reference angles, just go in half on the x-axis and follow that up. And that'll give you a 60-degree angle. the other direction. Make sure those things line up. So 60 degrees in the first quadrant has a reference angle of just 60 degrees. The first quadrant just says what its reference angle is. What is 60 degrees in quadrant 2? How much is that? 120. Because if we take 120 and then go 60 degrees, that'll land us at 180. 60 degrees after 180 will put us at how much? You just add another 30 to the 210. See, here's the 30 in between 30 and 60, and here's that same 30 in between 210 and 240. And if we look at the 30 between the 120 and the 150, that'll be the 30 between 330 and 300. So those are 4 angles that you would want to recognize and associate with 60 degrees. 60, 120, 240, 300. Those are all associated with 60 now. And finally, we want to recognize our 45-degree angles. So here we'll just go halfway up. And we will want to recognize our 45-degree angles, our 45-degree reference angles in each of the 4 quadrants. So what's 45 degrees in the second quadrant? 135. It's halfway between 90 and 180. So 135. And halfway between 210 and 240. 225. Halfway between 300 and 330. 315. You don't have to memorize all these values, you just have to remember them. You want to associate 45, 135, 225, and 315 with that 45-degree reference angle. How's everybody, okay? Any questions? Of course not. The most complicated thing we've done today is subtract. That's not too bad. So what we want to do is combine this information with the information down here. All my 30s are in this box. And the 30s in the picture are all marked in red. My 45s are all marked in green. And my 60-degree reference angles. So we can use this information to figure out the sine, cosine, or tangent of all of our angles with a 30, 45, or 60-degree reference angle. We get the value from what's going on in the first quadrant. We get the sign, positive or negative, from what's positive where. So it's just a combination of these 2 things. And of course, I don't have enough space to fill all this in. So everybody just take a minute and memorize this. I'll scroll slowly. I already have a picture of it in your mind. Well, some people are like, oh no, but I wrote it down, so I wouldn't have to memorize it. Now what we want to do is use what's positive where and what's going on in the first quadrant to figure out sine, cosine, and tangent of all these other angles, these other 9 angles. Then we'll figure out what to do at the quadrants. So we're going to get the value from what's going on in the first quadrant. I should say the absolute value. I should also say quadrant 1, because that's our abbreviation. Our value is going to come from what we know about the first quadrant. Our sign, positive or negative, will come from what's positive where. The absolute value is going to come from the first quadrant, and then the sign will come from what's positive where. So for example, if I wanted to know the sine of 150 degrees, we know that the 150 has a 30-degree reference angle because we talked about that once. We pointed it out one time, so everybody remembers it forever, because that's how math works, right? You saw algebra happen one time, so you'll remember it forever. I'm just kidding. That's a completely unreasonable request. But so we see the 150 and we say that's a 30-degree reference angle. I'm going to abbreviate as theta r. And we know that 150 is in quadrant 2. So 30-degree reference angle in quadrant 2. So now we put that together. Sine of 30 is a half. And in quadrant 2, sine is positive. So sine of 50 is positive 1. If we wanted to know the sine of 210 degrees, we know that 210 is in the third quadrant, and we have a 30-degree reference angle. So that tells us the value is going to be 1/2. But this is a 30-degree reference angle in quadrant 3. And sine is negative in quadrant 3. The value comes from knowing quadrant 1, all those 9 values in quadrant 1. Plus or minus comes from what's positive. Quadrant information. Any questions? Now it's just a mix and match, just some from column A, some from column B. So for example, if I wanted to know the cosine of 150 degrees, we'd read this 150 as 30 degrees in quadrant 2. That's our reference angle. So the cosine of 30 is √3/2. And cosine is negative in quadrant 2. If we want to know the cosine of 210, we have a 30-degree reference angle in quadrant 3. So we'll get negative √3/2. So the cosine of 210 is going to be negative √3/2. Because we have a 30-degree reference angle in quadrant 3. And cosine is negative in quadrant 3. Any questions? You don't have to memorize all those values, you do have to remember them. And it only seems like it's a lot to remember because it's a lot to remember, and you have to remember all of it all the time in perfect detail. But there's an awful lot of pattern running around that will help you remember how things work. And you don't have to sit down and memorize things as long as you repeat them enough so that you can remember them. I just realized I do have a spoon. It's just a little bit large. And it's also filthy. It's disgusting. Yeah. One of the classrooms I was in had a 2-meter stick. So it wasn't just a yard long, it was 2 meters long. It was like anime ruler or something like that. And I think it was for rooms like this one. Notice that even with this one, yardstick, I can't reach anybody to smack them. But if I had a 2-meter stick, I think I could at least get this first 2 rows. I don't know, this one's pretty thick, pretty good. At 2 meters, it's going to be really wobbly. This one's pretty stiff. So anyway. If you went to Catholic school, you know what I'm talking about. I taught at a Catholic high school once. Don't ever do that. It's like really bad for the psyche. We had these metal podiums that would sit up here. And I taught a class that was right after lunch. Don't ever walk into a room of like freshman boys immediately after lunch. It is like the stinkiest thing. It smelled so bad. It was an all-boys school too, so the school just smelled bad the whole time. Because it's like after puberty happens, but before the discovery of deodorant happens. Those are the bad times for your nose. I think that's the reason I have pretty bad sense of smell now. But anyway, students would come in and I just want to get their attention and I didn't have like a gavel. So one time I was like, oh, look, I have a ruler. And I thought I wasn't going to bang on it or the podium or anything. I was going to hit it a couple times like this. Order, everybody come to order. And everybody's like all freaking out and just, we were just in lunch. So I was just gonna come in and kind of like, hey, let's start working. But I came in a little bit hard, came in a little bit hot, and I hit the corner instead of hitting it flat. So instead of getting a nice smack sound, I kind of got that. And I kind of broke the ruler. So I go like I was trying to get people's attention, came a little bit too much of an angle, snapped off half the ruler, went flying into the first row of seats. Didn't hit anybody, which was good. And I was like, oh, that's funny. I broke the ruler. And I was going to laugh, but I couldn't because that shut everybody up. And so I just had to play it cool. I was like, oh, and I was about to go, oh, dude, what an idiot. That was funny. And I was about to laugh, but then I saw it worked. And everybody's sitting there going, panicked. And so I had to be cool. I just eyeball everybody. Stride into the first row, pick up the broken piece of ruler, and put it back. Then be serious for the rest of the friggin' day. Like, all right, let's begin. And everybody got their notebook out. Oh, nature's gonna beat us. So I had to replace the ruler. So I went and got a bunch of rulers, and the next day I walked in. I had like 5 rulers, 5 yardsticks. 1, 2. Just put them down individually, staring down the class because they were being quiet at this point. No one said a word until they were out in the friggin' hallway. I'm not like a scary dude. I don't know. So I put them down on the thing. All right. I got plenty of rulers, but I'm all out of patience. And then they shut up the whole day again. Anyway, what are we talking about? Oh, yeah. 2 things you need to know. What's going on in quadrant 1 and what's positive, depending on the quadrant. How do we copy quadrant 1 into the other 3 quadrants? Take a 5-minute break and then talk about what we're going to do at the angles.